Okay, so we did in the last video, I did the y components for you. So let's focus on the x, or the horizontal components of this. So what you have is, let me see if I can change the color a little bit. This might be easier to see. A little bit. Okay, so let's talk about your x, or your horizontal components in the x direction. Well, you have, I'm just going to draw a free body diagram down here for that. I'm going to draw my surface. I don't like that color, sorry. Okay, here. I will draw the surface to where it kind of looks blue. Okay, I'm going to draw the cart. Now, I'm not going to do any of my up and down stuff. I do know, if I look up here, that there is a tiny bit of frictional force. And so I'm going to do that, and I'm going to label that F sub F. And don't worry, there is no final force really you're going to be dealing with, so it's okay to use F for that. If it makes you feel more comfortable, you can go F sub friction like that. But I'm just going to use F sub F normally. And if you look, let's look, the side to side, part of your rabbit force here, this one, the one that's closest to theta, this way, will be force of your bunny cosine theta. And that's it. That's all we have acting in that direction. So let's remember, now this you are accelerating, so you can't say your net force is 0. So you can say your net force, you always want to write your net force, is equal to mass times acceleration. So therefore, mass times acceleration is equal to, well, let's look at your big force, the one that's accelerating it. That would be this, B, the force of the bunny, cosine theta. Now, I'm also going to look, is there anything else going in the direction of acceleration? No, that's the only one pointed towards this side of the page. And then is there anything slowing it down, going the other way? Why, yes, it's the force of friction. So we're going to go minus force of friction. All right, now remember, we want to solve this for acceleration. Well, if I hadn't mentioned that, we do want to solve this for acceleration. So I'm going to get rid of the mass, and I can divide this whole side by mass as well. So I'm just going to go in and erase the mass. So that means that your acceleration equals the applied force from the bunny, cosine theta, so the horizontal component of the bunny's applied force, minus whatever friction's holding it back all over the mass of the cart. So if you look at that, look, if the rabbit applies more force, cart goes faster. If there's more force of friction, see, because it's minus it, that would mean the cart goes slower. If you put more little veggies in the cart or whatever the rabbit's shopping for, then see how these are inversely proportional? That means that your cart slows down. All right, so that's how you find acceleration.